So at the bottom of the weekly prac, we have a question about a foraminifera living in the surface water. Okay, so often foraminifera are floating plankton, right? And when they die, eventually they will fall down to the ocean bottom, forming, this is a calcium carbonate, so a carbonate ooze. How quickly will it take it to fall? This is a really cool question because we use these foraminifera as paleoclimate markers, and if they take a very, very long time to fall to the bottom of the ocean, there would be, the ocean is moving, right? So these currents can take that grain of sand basically hundreds of kilometers away from where it was living before it lands on the ocean floor. We know now that actually the zooplankton eat the foraminifera and then fecal pellets drop down a lot quicker than this. But this question is saying, assuming Globigerina, which is this foraminifera over here, and it's much smaller than the ones you looked at in the microscope. So the ones you looked at are like benthic, they live on the bottom or shallow water. These are the mid-ocean ones, and they're very small. Planktonic creatures are usually very small. And here is omega. So this is the terminal velocity calculation. We need to know the radius squared. We need to know g. We need to know the density of the particle minus the density of the fluid. And we need to know the dynamic viscosity of seawater, which I give you over here. And we need to know 2/9. So I'm going to do this in Excel. I've provided an R script for those of you who would like to use R. But what I'm going to do is I'm going to create two areas. I'm going to have an area that's my yellow area that has all sorts of parameters that go in, and I'll create my calculation area and I'll make it like a nice color. Or a less nice color, I don't know, a different color. So first of all, what do I need? I need the density of the particle, the density of the fluid. I need to know the radius. I need to know g. I need to know mu, viscosity. So the density, let's find all this information here. The density of seawater, the fluid, is 1025 kilograms, and the density of the foraminifera is at 10% higher, so I could do 1025 plus 10% times 0.1, or you can calculate it with your calculator. The radius, okay, first of all, this is a diameter of 0.15 or 150 microns, and we would like half of that, the radius. 75 microns, right? We're talking in meters. I need to convert microns to meters. So I'm going to do this here. 75 microns in meter. It's over here. I'm not even trying to do it myself. G, what's G? Anyone remember the gravity? 9.8 meters to second square. And viscosity is this number. I'll just copy it. See how the meter thing is everywhere, so we needed meters. Okay, so here are all my values that I need to enter into into my equation. So what is my equation? It equals 2/9. It equals, I'm going to do all the different sections separately. This density, P, minus this density here. It has R squared, right? So let's write it up here. Equals this number times this number divided by mu, viscosity, times G times this number squared. So here is the terminal velocity of the foraminifera in meters per second. So how long will it take to reach the shallow ocean floor? So I have my terminal velocity, 0.0011 or 1 to the negative 3. And I'm going to say that in meters per second. That's how quickly my foram is falling. So if I had to fall 10 meters distance, which is a question, right? I need to, so time is distance divided by speed, right? Is 10 divided by the terminal velocity, which is 8,597 seconds. How much is that in minutes? Divide by 60. That's 143 minutes, or you can divide that by 60 again. It's 2.4 hours, so about 2 hours and 20 minutes. That's it.